2.5 is just an extension of what we did yesterday. So if I had 3x minus 5 equals 7, add 5. 3x is equal to 12. And then divide by 3, and I get x equals 4. Okay. Well, today we're just going to extend that a little bit. So look at number 2. Negative 8y minus 7 plus 5y equals 29. What should I do? No, we're gonna do this one. We need to, we could add 7, but we also need to combine like terms. So those two need to go together. So negative 3y, and then I add the 7 to the other side, equals 36. Divide by negative 3, and I get y equals negative 12. You guys good with that? I didn't say it gets harder. Actually, I did say that. Sorry. Okay. Look at number 4. Right. I need to combine like terms on opposite sides of the equation. So which way should we move the y? Move the 10 to the left. Does it really matter? No. Why would we move the 10 and not the 4? We like having leading coefficients that are positive. It will work both ways. But when we have a choice, we usually prefer to have a negative or a positive leading coefficient. So I will add 10y, and then I will subtract 7. So 6y equals 44. Divide by 6. Do 44 and 6 have any common factors? 2. So that would be 22 over 3. Oh, that's a subtract 7. You guys weren't paying attention. 30. And so divide 30 by 6, I get 5. That's a better answer. Okay. All right. Number 7. So yeah, they did get harder. What should we do here? Yeah, how do we get rid of the parentheses? Distribute. So I need to multiply the 2 in, and I need to multiply the 3 in, but remember, it's not just 3, it's a negative 3, and bring the negative with it. On the left side, we get 2v minus 6 minus 3 equals 21v minus 24 minus v. We just combine like terms. Which side should we put the v's on? The right side. How come? There are more v's on the right than there are on the left, and that would make the leading coefficient positive. So subtract 2v and then add 24. So on the right side, I need to put all three of those together. So 24 minus 6 is 18. 18 minus 3 is 15. And then on the right side, I need to put these together. So 21 minus 2 is 19. 19 minus 1 is 18. 18v. And then divide by 18. Does 15 over 18 simplify? Yes, they share a 3. So 5/6. Good job. Okay. All right. So sometimes when we solve an equation like this, weird things happen. So we'll do that over here. What if I had 2x minus 5 is equal to 5x plus 6 minus 3x? So pay attention to this because something weird is about to happen. Which side should I move my x's to? Should we move them to the right? So it doesn't really matter, but watch what happens. I'm going to subtract 2x, and on the left I get negative 5, and when I put these three together, what happens? Those turn into 0, and then I get 6. Does 5 equal 6? No. Okay. Now, I'm going to rearrange things a little bit. I'm going to write 2x minus 5, and then I'll combine like terms on the other side. 2x plus 6. Can 2 times x minus 5 be equal to 2 times x plus 6? So we have this number minus 5 is equal to the same number plus 6. That doesn't work, right? 8 minus 5 cannot equal 8 plus 6. So this is an impossible equation. So if you solve an equation like this and the variables disappear and you end up with some false statement, what that means is it doesn't matter what number you pick. None of them will ever work. So sometimes you can see it when you start the equation. So x plus 1 equals x plus 2. That can't happen. X plus 1 cannot be equal to x plus 2. So the answer, the solution is no solution, which means there are no numbers that work. So on this, it gives you the option, no solution, or if it does have a solution, then you just write it, or all real numbers. So let's do something similar. If I had 6x plus 3 minus 4 is equal to 2x minus 1 plus 4x. Let's move all the x's to the left. So subtract 2x and subtract 4x. So this gives me negative 1 equals negative 1, and that turns into 0. Does that make sense? Well, what does this mean? Yeah, so we say infinite solutions, but what does that really mean? Any number works. So if I was to look at x minus 3 equals x minus 3, what number makes that true? Any number. If you plug in 2, 2 minus 3 is negative 1, and 2 minus 3 is negative 1, so 2 works. 20 also works. Every possible number works. Okay? Now, sometimes when you deal with more complicated equations and you get infinite solutions, it doesn't mean every number works, but it does mean that there are an infinite set of correct numbers. So if we solve this one, we might end up with something like 6. If we end up with 6 equals 5, that would mean no solution. If we end up with w equals 3, then it means that there's one answer and we just write it down. If we end up with 0 equals 0 or 1 equals 1, that means all real numbers are solutions. Does that make sense? So if the variables disappear, you either have infinite or no solution, and what's left will tell you which one it is. So let's solve this and see what happens. Distribute the 3, 6 plus 3w minus w, and then 6 plus 2w plus 2. Can you look at this and figure out what it's going to be before we solve it? What's it going to be? No solution. Because we have 2 w's on the left and 2 w's on the right, but the left side is equal to 6 and the right side is equal to 8. Is 6 equal to 8? No. So this one has no solution. Okay. That does it all. Get to work.